Hi everyone. So today we will focus on heat of neutralizations. Previous lesson we already learned about heat of precipitation and also heat of displacement. So in heat of neutralizations, what you need to know is you have to know how to define the heat of neutralization and how to draw energy level diagram and also calculate the delta H of reactions or calculate the heat of reaction in neutralizations. So in this chapter, you also will learn how many heat has been given off when strong acid react with strong alkaline and weak acid react with strong alkaline. So this is examples. Let's recall it. What is neutralizations? In neutralization, meaning acid react with alkaline to produce salt and water. So like the diagram here, it mentioned acid HCl react with NaOH, it will forming NaCl plus H2O. So what actually heat of neutralizations? So from heat of neutralization, we can write the ionic equation. There is H plus react with OH minus and form water. Or you can refer the balanced chemical equations here. So based on these two, what actually heat of neutralizations? In previous lesson, I already mentioned that there are thermochemical balance equation. So this is one example of thermochemical balance equation when you write delta H in the balance chemical equation. So for this reaction, the delta H is equals to negative 57.3 kilojoule per mole, meaning here this is the value of heat of neutralization. Okay, now we focus what are the definition of heat of neutralizations. So heat of neutralization meaning the heat energy released when 1 mole of water is formed from the neutralization between 1 mole of hydrogen ions H plus from an acid and 1 mole of hydroxide ions OH minus from an alkaline. And below there is the formula. Okay, then next we learn about how to draw energy level diagram. In previous lesson, we already learned that this is the thermochemical balance equations. So after you write balance equation of the reaction, we can write the delta H value after the chemical equation. Then from here delta H, the value is equals to negative, meaning it is exothermic. So we have to draw arrow going down. And then we also know the delta H of the reactant is greater compared to the delta H of the product. Then we write the value of delta H. Next is the experimental neutralization. After the video, so now we want to see how the procedure step by step to undergo the experiment to determine the heat of neutralization between a strong acid and a strong alkaline. You can take any strong acid, for example HCl, NO3, nitric acid, and also sulfuric acid. Okay, so you can go through. Okay, next we see the reaction between strong acid and strong alkaline will have value of delta H is equals to negative 57.3 kJ per mole. And for reaction between weak acid and strong alkaline, it will have lower value compared to the strong acid. There is negative 55 kJ per mole. So why this happen? Why weak acid and strong alkaline have lower value compared to strong acid? So let's recall our prior knowledge. So you already learned in strong acid, it will produce higher concentrations of hydrogen ion because it has been ionized completely in water. But for weak acid, you just ionize partially in water to produce lower concentration of hydrogen ion. So because of that, the delta H of the weak acid will have lower value compared to the strong acid. Same goes if we use weak alkaline and compare with the strong alkaline. So weak alkaline also will have lower delta H compared to the strong alkaline and strong acid. So this is the explanation why it have lower value. Next, I give you all the tables that have 4 reactions between acid and alkaline. So if you refer first and second column, both have strong acid and strong alkaline reaction. Because of that, it have the same amount of delta H that is equals to negative 57.3. Whereas if you use weak acid and strong alkaline or strong acid with alkaline, you will have lower value than 57.3. Okay, next we will focus on calculation to determine heat of neutralization. So based on whatever you already learned, so the formula is delta H is equals to Q over N. So your first step is you have to determine Q by using formula MC theta. And then after that, you have to find number of mole of NaOH and number of mole of HCl. Then you find by using Q over N, you can determine the delta H. And then after that, you have to draw the energy level diagram. So based on that one, so again, the formula that you need to know is Q is equals to MC theta, and then find the number of mole, and delta H is equals to Q over N, and then draw energy level diagrams. Okay, bye. Okay, I hope you understand today's lesson.